A specific example of how to do the disk method, a solid of revolution. So in this problem I'm given a function. It tells me f of x is equal to square root of x plus 5. They want me to revolve it about the x-axis, and they give me boundaries, basically tell me where to start and where to end. So I'll start with a picture. As they say, a picture's worth 1,000 words. I start with rad x plus 5. So that graph's a little something like this. And then I'm being told to start at x equals 2. So I go, there's x equals 2. And to finish at x equals 4. Because I want to do a solid of revolution, they're telling me to rotate this about the x-axis. So as I rotate this about the x-axis, most usually just do this curved arrow, it's going to sweep out this region that comes down here. You're going to get like that mirror image of it. And I'm looking at this as just a big disc shape. You imagine that as just a disc. It's being a band right there. Now, in order to do the calculus, I'm simply going to say my volume is equal to the integral from x equals 2 to x equals 4. My radius, I have to go from my axis of revolution and determine what that radius would be. That's going to be that length going all the way up here. So it's going to be this function right here that I have to square. So I'm going to take my pi, I'll put that on the outside. It's just a number, so I'm allowed to pull the pi out. I'll take my function, I'll call it rad x plus 5, that gets squared. That's my pi r squared. And then because I'm going to have an infinite number of these disks to create this solid shape, again I'm using that analogy of like a 3D printer. It's going to do one layer, one layer, one layer. It's just going to keep printing that out until I get this three-dimensional object. And each layer is infinitesimally small. We simply call that our dx. So I'm looking at a pi r squared, and there's my height. Now, I'm going to be a little bit lazy here. I'm going to use my calculator because I want to show the analogy that we used with areas. How when you put this into the calculator, you're not going to see this picture. You're not going to see a three-dimensional object, but you will be able to extract an answer that represents that volume. And the way you're going to do that on your calculator, see, I'll show you. Here's my original function. I have that already pre-graphed. But that's not what I want. I don't want the square root of x plus 5. I'm supposed to be squaring that entire function. So I'm going to put parentheses around all this. Whoop, hit the wrong button there. So I put parentheses around that function. I square it. And if you want, you can put the pi in front of it. It does not really matter. I usually wait until the end and put pi on there, but I'm going to go ahead and put it, for this example, right in the front. I do my pi. Oh, it'd help if I could hit the right buttons. There we go. Making sure that your function is still in parentheses, because it's the function that's being squared. Now, it doesn't really matter that I graph it, but I'm going to go ahead and graph it. It doesn't even graph on my standard grid, but that's okay. Because what I want to do with this, I'm going to do my second calc, go to option 7, where I do that integration. I'm going to start at 2, because that's what it was telling me to do here, and I'm going to end at 4. And as it does the area, I know what I said, it said area. It's going to give me the area represented on the calculator, but that area is actually the volume of what I've drawn on my paper. And so I can immediately say this is equivalent to, now because I put my pi in there already, this is just going to be in a decimal approximation. My calculator was reading as 284.242. 242 units cubed. Why cubed? Because 1, 2, the square, that's 1, 2, 3 dimensions. 1, 2, 3 dimensions. Pi r squared height. That's just a cylinder, or a disc if you will. And so there's your first example of how to do the disc method.